Okay, let's get started. All right, so today is examples, a very descriptive lecture name. So this is our first of several / many, not too many actually, but first of several kind of open-ended examples lectures. I like to do this, especially when it's the last Friday of a block of content. Like this has all been the homework 1 content, and then starting Monday is going to start the homework 2 content. So the last Friday of a block of content, I like to do it open-ended and just show you examples, which is mostly homework help. So anything that will help with the homework, that's what I want to talk about. When I do these lectures, I like them to be open-ended. If you have questions, something that's really tripping you up on the homework, I want to hear those questions and then tailor my examples to those questions. But I do have a whole bunch of stuff prepared, so if nobody asks questions, which fairly often there's not many questions in these lectures. So I'm always prepared with what I think will help the most, and I'll show what I think will help on the homework. So a reminder, homework 1, these are due the Monday after the block of content for the expected deadline. If you're not well on your way to finishing homework 1, you should be. You definitely should get there soon. So anything that's in your way, you're getting tripped up on, that's what we want to talk about today. Question?
I just have a question about the favor icon.
Mm-hmm.
You wanted that to show up on every page that you have with that website. Did you have to serve an HTML file every time?
So if you want the fav icon showing up on each page, would you need to serve HTML? I think the browser will default to calling it favicon.ico and just send that request, even if it wasn't requested with HTML. But to be sure, you would want to serve HTML and then put it in the...
It's like when I go to this kind of page, the browser kind of doesn't show up.
Yeah, and that's fine for the homework. The homework only says, and in general, by the way, the homework only says, for that objective, it only says go to the root path. My test and procedures, and I just had our TA meeting yesterday and reminded them all of this. If the test and procedure doesn't say it, we're not testing it. So the test and procedure, if you're only worried about grades, I don't know where the question is for that. If you're only worried about grades, look at the test and procedure. We're only checking the root path. That means we're not going to, I'm blanking on the name of it. We're not going to visit counter. We're not going to /visit counter and making sure you have favicon there. The test and procedure only says go to the root path. So that's the only way, the only place we're going to go to check that favicon. So in general, test and procedures to the extent of when I'm talking to my TAs, we're going over how we're going to grade the following assignment, and they say, Jesse, you just mentioned this thing that you talked about in lecture that you want them all to do, but I don't see it in your testing procedure. I'll say, crap, I guess we're not testing that. And then we just miss out on that. We just don't test you on that. It's got to be in the testing procedure. I will hold to that. These are the same exact procedures that the TAs are going to follow. I don't give them extra instructions. The only thing we talk about when we talk about grading, the only extra instructions that we do talk about is when the testing procedures fail, should that be a 1, a 2, or is it minor enough that we'll still give you the 3? Those are the only things we talk about behind the scenes. Like if the testing procedure fails, what's the partial credit that we're going to give? Other than that, if the testing procedure passes, every single step of the testing procedure is good, you're good. So I gave you a longer answer than the full question. But I like to remind everyone of that because it covers the answers to a lot of questions. And this setting the value to 100, I do see some students who will only read, instead of fully parsing your cookies, just get the last character of the cookie's header and treat that as the visit counter. Well, the testing procedure, I had to double check my testing procedure to make sure it worked. But testing procedure says 100. If you're only reading the last value, you're going to treat that as a count of 0 and then increment it to 1 instead of 101. So things like that, they're covered. If they're covered in the testing procedures, then we're covered. Then you have to make sure you do them. One of those things is making sure your no-sniff header is properly set. I do see a lot of students each semester don't set the no-sniff properly, where it's there in the response, like you remembered to put it there, but if it's not properly set, it's not actually disabling no-sniff. That is one thing we look at specifically, but it's right there in the testing procedure. All right, any other questions? That means everybody's doing great on homework one. Yes.
We're adding the X content type options, no sit manually, right? In the headers.
Yeah. Yeah, you're gonna type that in your responses. Yeah.
Is the way it's spelled right there syntactically correct?
This? Oh, I would have usually just said yes, but now you were going to make me doubt it. It's it should be.
I
Yeah.
just copy and pasted that, and you said it has to be sent specifically, so now.
Yeah, it should. I mean, if that is, I'm like 99% sure that's right. If that's wrong, though, I can't really hold that against everyone. If it's wrong in my testing procedures, y'all get a free pass. Yeah.
In the next objective, when you open the second browser, are you supposed to close the first one? And like,
Either way is fine. So your cookies are going to be specific per browser. So if you have Chrome for the first test and then you open Firefox, Firefox won't have that cookie set. So that's what I'm getting at with step 9. So whether you close Chrome or not, Firefox isn't going to care. It's not going to make a difference in the testing procedure. So either way, if you close it or not, technically, and you can get your lawyer hat on for some of these testing procedures, technically it doesn't say to close the first browser, so the technical answer would be it stays open. Just because nowhere in here do I say close the first one. Yeah?
Are you going to modify the cookies in Chrome? Because it only works in Firefox. I couldn't find it in Chrome.
Yeah, so go to, if you right click and go to inspect element. So the question is where can you edit the cookies in Chrome? This is Opera, but it's a Chromium browser. It has the same browser console. It's an application. I don't know why they name it that instead of storage. But it's an application, and then cookies, and then I can see all my 0 cookies for CSE 312. And this is, I don't always say explicitly what's being tested in each one, but just to use this one as an example, since I talked about half of it already. This step 6, close the browser window, is important. So we're closing the entire window and then restarting the browser. The reason for this is if your cookie is a session cookie, that's going to reset that cookie. The session cookie is until the browser window is closed, not the tab. If you close the tab and reopen it in a new tab, that's not going to reset a session cookie, but closing the window does. So the TAs are going to do that as a way of verifying that it is not a session cookie that you set. Because nowhere in here does it say go into the browser console and verify that it's not a session cookie, but that step right here, close the browser, open it up, and make sure we got to 3, that's going to check if you have a session cookie or not. And then the next one is making sure that you're not keeping track of the cookie. Some students like to have a variable that's just incrementing on the server side and then serving up that variable without using cookies at all. I've seen students do it. They don't get credit because I always had this because I'm always aware of that loophole. Go to a different browser. If that browser is showing 4 on this step instead of 1, then I know you're not actually using cookies. You're instead just keeping track of the number of visits server side, and that number of visits is global to all users, which is no good. So all this is designed to make sure you're using cookies and not using session cookies. Yes. That's actually one of my prepared examples. I can do that one first, since there's demand.
Just a super
Yeah.
fast question. If you log in on the same browser in two different accounts, those should be different cookies, right?
If you log in the same browser in two different accounts,
Like I have two different Google Chromes, one open up my workflow and one open up my personal. Would those have two different?
so you have two browsers, like two Chromes open,
Yeah.
two different windows.
Yeah, two different
They
windows.
should be sharing cookies, if I'm not mistaken. But Google specifically that you mentioned, wait, did you mention Google?
Yeah, I'm in Google Chrome.
Okay.
I have two different windows open, one under my buffer.
And what app are you using though? Like what services are you logged into? Because like if it's Google specifically, the Google supports multiple, like being logged in as multiple users, and then you can switch accounts like on a per tab basis.
So the way I have it set up on my computer is they're completely separate from each other. They're not actually, so like when I load up Google Chrome, it gives me an option to sign in as one or the other. It's not where you pick the drop down.
Okay, yeah, that's
Effectively, two separate browsers.
okay. But it sounds like that's a Google feature, is what I'm getting at.
Yeah,
Because the Windows should share cookies.
okay.
But if you're using Chrome and logging into Google, Google just has a lot of extra functionality there.
Yeah. Okay. Gotcha.
But if you go to here, I'll give a demo. Like I'm logged in. If I open up a new window and go to, I don't know, Google Drive, of course I'm going to get interneted. Go to Drive. I'm still logged in on a brand new window because it's sharing my cookies from the other window. It's
Yeah.
Chrome is sharing all those cookies. But Chrome has extra features where it's reading those cookies and then letting you decide which profile.
Okay.
Because I can go here and switch profiles. I think I'm only logged in on one at the time. Yeah, I'm only logged in on one account right now. But yeah, the browser windows should share cookies. But if I open Firefox or Chrome, those cookies are not shared. Yeah.
Would, like, let's say that the tester, we're looking at all of our submissions, would the cookies start like overlapping because it's the same path, or how does that work?
The TAs will clear cookies. So that's not explicitly in the test and procedures. That is one thing, I guess, that I tell them separately, is for each student, make sure clear cookies each time. I guess the testing procedures assume that everything's a clean slate when you start. Okay, let's get to that image question. So I have here a quick example. Let me delete this first. Quick example, I have an image here. It's a PNG, but same concept applies to your JPEGs in the homework. This beautiful image. And, and I want to copy the file. All I'm doing is reading the bytes of the file and saving those bytes as a different file. So I'm going to copy this file. I'm going to open twitch.png and save it as copy.png. And I'm going to use this code. So this is how you're reading your files in Python. No surprises here, hopefully at least. You've been doing this since 1.15. So with open, the file name that I want to open, this part is a little different. This is the part I'll talk about, this B specifically. As file, file.read, instead of doing read all lines like we did in 1.15, what we have to do is make sure that we're reading this as bytes. We want to read the bytes of the file. Read all lines. There's no concept of lines in an image. It doesn't make sense. It's not going to work the way you want it to. But file.read is going to read all the bytes of the image. I'm going to save it in this byte array. Open the second file name with WB. I'll talk about that. And write all the bytes into a new file. Now, you won't be saving files until homework 3, but this is how we'll save a file. But I'm just trying to get a minimal example of reading a file and doing something with those bytes. So we'll run this code. Run it. look at my copy, and I have a copy of that image. Everything went great. Go us. So what I did here was read the file. I'm using RB as the mode of opening this file. So read, R for read, and B for bytes. I'm going to read this as bytes. And then when I'm writing in write mode as bytes. That B is very important to make sure I'm reading and writing in bytes. If I don't do that, and I run this file, I'm going to get an error. I have a UTF decoding error. Can't decode byte 89 in position 0. The very first byte of this image got a decoding error because it's trying to read this as a string instead of as bytes, and it can't decode the image as a string because it's not encoded as a string. It doesn't follow the format of UTF-8, where every byte either starts with a 0 and the 7 bits are ASCII, the remaining 7 bits are ASCII, or starts with the number of 1s equal to the number of bytes, and then continuation bytes starting with 1, 0. My image isn't going to follow that format at all. It's still bytes, sure, but they're not going to follow that format unless by some absolute miracle the bytes all just happen to line up and be able to be encoded as proper UTF-8, which isn't going to happen. It's never actually going to happen. So I want to make sure I read it in bytes so I get the bytes of the file, not reading the file as a string. Reading this without byte mode is going to read this as a string. And you can see when I delete one of the B's, this is going to be an error because I have this as a string and I'm trying to write in binary mode. And that's going to give me an issue. Bytes and string, not the same, can't do it. I could get rid of the error by encoding, sure. But it's still going to be the same issue because I can't decode. When I'm reading this is expecting a text file. I don't have a text file, I have an image. So never ever treat your image files as strings that we talked about in the slides a whole lot. Here's what I'm talking about. This is what I'm talking about exactly. We can do this in a little bit different way. That's obviously bad. That's why I have copy file bad. But let's try it a little bit different way. I'm going to read it in bytes. So this is still going to work fine. But then I'm going to convert this to a string. Just blatantly convert it to a string and then save that string in bytes to my second file. But at some point along this process, my image was converted to a string and then saved to the new file, or I'm using those bytes that were at one time converted to a string. And this one actually, works. It works, right? I didn't crash the program, so you're going to be tempted to say, okay, this is all right. And then you go to the browser and your image doesn't show up. It's because those bytes were corrupted. So this one doesn't throw an error, but since those bytes of the image were converted to a string, the way I converted it here, Python just kind of guessed what I wanted. It took those bytes, said, these are not string bytes, but just gave me something. It just picked what those values should be. And then by the time I encoded it again, this is encoding valid text, because we did actually convert this to a string. So this is valid text, but when I encode it, it's going to be encoded as UTF-8 bytes, valid UTF-8 bytes, and they won't be the same bytes as my original image. Those bytes got corrupted along the way because they were converted to UTF-8 and then converted back to bytes. I lost information there. Not going to work. Your image has to never, ever, ever be converted to a string. So in your homework, what you would do is read it as bytes, and this is in bytes, and you never, ever, ever want to convert it to a string at all. So what you'll have are your HTTP headers, /r/n/r/n. You're going to have this, and what some students are tempted to do is b.decode. You're going to be tempted to do something like this. And then when you go to send, you would encode. Some students are tempted to do something like this because you have to combine your headers that are string to your bytes of your image, which are just any random bytes that encode this image. You need to smash them together somehow. So, well, why not convert your image to a string with decode? Well, you just messed everything up because once you hit decode on your string or on your image, you're converting your image to a string, and that's not going to give you what you want. And I forget if this one crashes or if it just gives you bad bytes. It crashes. So this one crashes. Doesn't give you what you want. The solution here, never, ever, ever touch the images, the bytes of your image. You read it from the file in byte mode. That's it. Do not touch those at all. Do not modify them. Your content length, len of b. That's it. And to concatenate it with your headers, just encode the headers and then add them. Now you have your 2 cent. So encode your string as bytes. Now I'm encoding my headers as it's a string. I'm encoding it to bytes. This converts my string into bytes. And my image is already bytes. I got bytes here. I got bytes here. And Python has this very nice concatenation operator that works with bytes. Just smash them together with the plus sign. That's it. Don't overthink this one. But make sure your image bytes are never, ever, ever, ever treated as a string. Because they're not. It's not a string. It's not a text format at all. It's not UTF-8. It's not ASCII. It's not any other encoding, and no string encoding. It's PNG encoding in this case. It's not going to follow the same structure. Okay, I did miss something in chat. The first time you visit a site, there should be no cookies header in the request header. That is correct. And then after the site is visited, we set the cookie, and a cookie header should appear in the request headers. That is also correct. Yes. Is there a difference between with open as syntax and open syntax? Yes. I'm glad you asked. So file equals open file name RB. This will work for you. The difference is with open as is going to make sure that that file always closes properly. So if I open my file like this, somewhere at the end here, I should have file.close. And I got to remember to put that there. And if there's an error somewhere in here, something goes wrong right here maybe, I get a file not found, then this file isn't properly closed. But when I have the with open as, it's going to make sure that my file is always closed no matter what goes wrong. So it's just good practice to use the with open as. Yeah.
So in the contact of the project, would it like be fine if we don't include the file.close, or should we like adjust the file.close?
As long as your code works, I'm not concerned. For best practices, like you should get in good habits. Or else when you get to your first job, somebody's going to yell at you on day one if you're doing that kind of stuff. Not making sure your file's closed. Because that's how files get corrupted and bad things happen eventually. It'll catch up to you. Yeah.
So if you wanted to create a function that reads all type files, you use RB or .py, .html file.
Yeah, so this is something I do recommend. I'm not going to be mad if you don't do this, but it can clean up a lot of your code. Is even if you're reading an HTML file, you can read it as bytes. There's nothing stopping you from doing that. You can read it as bytes, and then you don't have to worry about encoding it and making sure you get the length of it at the right time. You don't have to worry about any of that stuff if you just read it as straight up bytes first. It would be the same as reading the file and then converting and then encoding it after reading it. Just read it as bytes straight up. Don't worry about it being text at all. Yeah.
So if you do read it as bytes, then you don't need to encode it at all.
Right. Yep, because it's already encoded. In fact, if I read this and try to encode it, b.encode, because like this Python code doesn't know that I'm opening an image. It just knows that I'm opening a file, which could be absolutely anything. But I'm reading it as bytes. I'm saying, just read the bytes. So this is going to be bytes. I can't encode bytes. It won't even let me. It'll give me an error. Yeah.
For the indentation with open file name and all that, is everything after that indented?
Yes. Yeah, so this creates a code block, just like an if statement or a loop. So this is inside that code block. That's why I had to unindent when I switched to the other format. And really, this should be wrapped in a try, and we should do all that. But with open as, you don't have to worry about your try except block. Yeah.
Do we close after we send the response back to the user?
I would use with open as, and then you don't have to worry about closing the file at all, personally. But it would be up to you when to close. I would like to close it right when I'm done with that file. So I would read the bytes. I would probably close right then, if it were up to me. I don't want a file, I don't want any resource being open longer than it has to be. That said, in my original file, I did have file open longer than it had to be, so I don't always hold to that, but. I'm even breaking some naming convention in this. Yeah, I'm not going to change that. All right, any other questions on images? So we started with Objective 2, the second half of Objective 2, I suppose. Any other questions on this one? Yeah.
Not necessarily about this, but with the file close, if you did it directly after you read, and then you say that to a variable, would that really affect your code at all?
Would that affect my code at all? What do you
Would
mean?
it affect, like,
It wouldn't affect the behavior of the code.
okay,
No.
so it would really affect
It just gives less time for something to go wrong with this file. I want to make sure it's closed before something crashes in my program, and then it never gets closed, and the operating system thinks I'm still reading those bytes. I just would like to avoid that stuff. With open as, Python takes care of all that for me, and I don't have to think about it. It's a nice feature Python added. Do we need to handle all the pictures in the folder public images? Yes. Why doesn't Python handle that automatically? If you're talking about file closing, it does if you use with open as. Then we don't have to think about it. How would you remove the cookie after you set it? You can't. Can't do it. You could set it to a blank value. I guess you kind of can, now that I think about it. You can't really, but I would set it to a blank value within expires in 1 second, and then the browser will clear it. I think that's kind of a workaround. You can't actually delete it, but that would be a workaround to get there. Or you serve JavaScript that's going to delete the cookie for the user. Why do you have to write the bytes to a new file? Can't we just send the bytes? Yes, this is just an example. Bless you. So when I do examples in lecture, I'm showing you the concept. I'm not just going to give you the answers to the homework. You would never write to a new file. I'm just doing that to show that when I write to a new file, doing it the wrong way, those bytes that I write are not the right bytes. So for your purposes, you're not going to write to a file. You're going to send that in the HTTP response. But if you do that same mistake, the bytes that you send in your HTTP response are not going to be the image. They're going to be whatever these bytes are for this corrupted image. So we don't want to send those corrupted bytes in the HTTP response, just like I'm saving the corrupted bytes in my copy of this file. So no, you'll never write a file. Well, until homework 3. Homework 3 is image uploads. Your users are going to be uploading images, and you'll save those to a file. You'll read the part of the body of a post request and then save those bytes as an image. Yeah.
What's the difference between sending a file like an HTML file versus sending a JS file? Should I just be changing the content type?
Yes, just the content type. Mm-hmm.
And if I'm doing emojis, I'm just adding the char UTF-8 extension on the content type.
Yes.
Yeah.
Mm. And it doesn't harm to always put that there, too.
Right.
Because even if it's ASCII, it's still UTF-8. All right, let's get to the next example. I have some code here that's going to take in a string. It's going to encode it using UTF-8. So I'm going to convert that to bytes. I'm going to print it out as a string. So the input as a string, I'm going to print it out encoded. And then I'm going to print it out in a few more ways as decimal, so we can see what the UTF-8 or ASCII value of that thing is. I'm going to print it as hex, and I'm going to print it as binary. I'm going to print the length of the string and then the length of bytes. This, of course, is the big part that we have to concern ourselves with. The length of the string is not always going to be equal to the length of the number of bytes taken to encode that string. Then I have a few strings here. Hello, 3/4, and then a few, I forgot what these other ones were, sorry, but hopefully these aren't anything ridiculous. I don't think they are. I forgot what they were. And let's run this and see what we get on these characters. And hopefully I've hammered this down enough in the lecture slides that we can predict what's going to happen with these. But let's see in action just to make sure we get this point home. So hello, if we look at this as a string, it's hello. As a byte string, it's hello. So these are going to be bytes. This is the byte 6.8, the byte 6.5, etc. But when we print out a byte string, Python's going to help us out a bit and say, whoa, those look like ASCII characters, and replace anything that looks like an ASCII character with its actual character. Only for us humans. This is, at this point, a sequence of 5 bytes. But when it prints it to the screen, if it's a valid ASCII byte, then it's going to print it as ASCII, which can get confusing when you have mixed ASCII and non-ASCII characters, which we're going to see in one of the next ones. But these are bytes. These are the values in decimal. You can look up your ASCII chart. These are going to be the values for lowercase h, e, and l. These are the same values in hex, and this is what's actually sent over the internet. When you print out something in decimal like this in Python, it does remove the leading zeros, but we can count and see that there's 7 bits here. So we do know we have a leading 0 in the most significant bit. And you've seen these before, at least in 220, probably in 341 and a few other classes. OX, if the prefix is OX, it means it's a hex value. If the prefix is OB, that's going to mean this is a binary value. So we can distinguish between like 1000 and 8, like this. We don't want to treat this as 7. There's no prefix, so we know that that's a decimal number. So it just helps us distinguish between them. String length is 5, byte length is 5. Everything's pretty straightforward with hello. So let's move on to our first more complicated one. We have the symbol 3/4. This is a valid UTF-8 character, but it is non-ASCII. Now we have a non-ASCII character, and we can see when we print out the bytes, since neither of these bytes are valid ASCII, Python can't help us out here. It says, I don't know what these characters are. Sure, it could figure it out and assume that it's UTF-8, but if it's like an image that we're printing out, it's not going to be correct if we do it that way. So we have /x. Don't ask me why they didn't use OX. /x is a prefix to say that this is hex. C2 and then BC. So we can see what the bytes are, the actual bytes. And if we print this in binary, it's 110 is the prefix of the first byte, meaning that this is a 2-byte character, and then the second byte is going to start with that continuation byte, 10 at the beginning, and then the remaining bits are going to be the actual values for this character, this specific character. And now the string length, it's only 1 character, but when we encode it in UTF-8, 2 bytes. We got 2 bytes for a single character. That's the big key takeaway. If you're computing your content length as the length of the string, you're only going to get one of those bytes in your browser, and it's not going to display properly. You're going to get all kinds of issues with your encodings. 3/4, and then the euro sign. This, the one thing I want to highlight here is the space in between them. Since it's an ASCII character, Python's helping us out. I kind of wish it didn't do this. By rendering the space as an ASCII character, as a character that we can read, human readable, but the non-ASCII characters, it just spits out the bytes because it can't render those, or rather doesn't render those. So it helps us out only with ASCII characters. And we can see string length 3, byte length 6. different. We have a character that's 3 bytes, string length 1, byte length 3, and we can go all the way up to byte length of 4 with UTF-8. So this is a single character. If you're getting the length of your string and you have a lot of characters like this, these 4-byte characters, you're going to have 1/4 of your data sent, which obviously isn't going to work out for you. So make sure you're getting the length after encoding in bytes, not before. And for what it's worth, since hello is all ASCII, we can encode it with ASCII. So encode and decode do take the encoding type as a argument. If you don't do anything, it's going to assume UTF-8. That's the default. But if I encode it using ASCII and decode it using UTF-8, well, this works. This works just fine. And this is something not relevant to what we're talking about yet. And I guess I'll mention this since it's on screen. You can manually create your byte strings if you know the bytes to your characters. Usually this isn't what you want to do. But you can just specify the bytes in that same syntax. Right, like this. Decode it as UTF-8, and it prints as that character. When is homework 2 going to be released? Before Monday for sure. I can go over what homework 2 is going to be. I have it mostly ready, just not completely ready. It's going to be authenticated chat. So the first objective, LO1, is going to be unauthenticated chat, so you can read your first post request, where the body of the post request is going to be JSON formatted text. You'll read that JSON, decode it as JSON text, and get the message that the user is sending. Add it to the chat history using a database. There's going to be a lot of moving pieces with this. Add it to your database and host a path where somebody can request all of the chat history, where you go to your database, read every message that's been sent, and then send it to the user over that path. 2 is going to be add authentication to that. So users are going to create accounts, log in with those accounts. You're going to securely store their passwords in the database and their user accounts. And then when somebody sends a message over chat, instead of just saying, okay, let's throw this message in the database, you're instead going to verify that they are logged in, or rather, I think I'm going to allow guest chat even when after you do Objective 2, just because it makes grading easier. If something goes wrong with Objective 2, I still want you getting credit for Objective 1. But you're going to check, are they logged in? And if they're logged in, you're going to pull their username from the database and then attach that username and say, this user said this message, instead of just adding the message to the chat with guest next to it. Objective 3 is going to be, I got to think a little. What did I decide Objective 3 is going to be? It's something really important, but hold on, we'll get there. I came this far. I want to give you all a heads up of what to expect. Editing, it's the REST API. Editing and deleting messages and making sure that only the user who posted the message can edit and delete that message through 2 different endpoints using put and delete method types. And then the application objective is going to be cross-site request forgery tokens. So attaching tokens to the form so nobody can send a message through an attack site and have send messages on somebody else's behalf. So that's going to be homework 2. I'm still getting the document written and wording it all up. I'm going to have some starter code. A lot of the front end I'm going to give to you. So I'm making, if you all want to see a beautiful front end. I'll show it to you, so then if it gets any better before the homework handout, you can be like, wow, that's so much better. That's so good now. That's not it. There it is. So if it looks better than that by the handout, be happy. But yeah, that's the quick rundown of homework 2. Actually, I have homework 3 designed too. I haven't been thinking about that as much, but I think I have that one. It'll be DMs, adding DMs to that site over WebSockets. So having a user list, you can click on the user, send them a DM, they get it immediately. Image uploads, so instead of just posting to chat, you can post text and an image. That's the big image upload thing I've been foreshadowing quite a bit. And I don't know what the third one's going to be with that yet. Those two are really heavy already. So the third objective is probably going to be adding one like small feature to one of those two things, because there's a lot going on already with that one. And then the application objective will be WebRTC, doing video chat between users. It's not as bad as it sounds, really. It sounds bad. It's not as bad as it sounds, though. Okay, so I got one more demo I want to go through, or at least one more demo that I have prepared. What's the difference between get and post? Post is when you're sending information to the server, and get is when you're getting information from the server. So when we start doing chat, it'll be post request because you're posting your chat message to the server. All right, so I have the homework handout, I believe unmodified. Oh, I added just the send all at the end. Mostly unmodified, but I believe I did this during lecture, so I don't think that's a big surprise. Starting the server, and I want to go to the site, which should just say hello. Did it not? Oh, because I have my content link purposely off. But that's fine. That's all I wanted anyway. So I can see my request in the browser. And I want to talk about everybody's favorite topic, testing. How do we test this stuff? I'm going to talk about this in a few different lectures this semester because I get really sick of nobody ever testing and then coming to office hours with issues that you could have solved in seconds instead of spending hours on them. So let's talk about testing a bit more. So I have this request method that I gave to you, and the reason I set this up is because it's easier to test. Now, part of that is for the grading side that we can test this easier, but also you can take advantage of this structure too, and in fact take this lesson and use it in future homeworks and build your code in a way that makes it easier to test is a wonderful, wonderful thing. But I at least want to show you and give you a little guidance on how to do that. First, I'm going to write a main method. And I'm going to set up just a little infrastructure here. Main method that calls my main method. I don't really feel like talking about that right now. Maybe somebody asks later in the semester, I'll talk about it. But this is a good way to set up a Python program, and there are good reasons to do that. And I want to test this code. So what I'm going to do is have some input. I'll call it input. You know what? Let me label it a little bit better. HTTP request. There we go. We got there. And then I'm going to get my request object based on this HTTP request. So I'm going to have the bytes of a request and create a request object. And then I want to make sure that this object that's created has all the information that I need. So I can run this. My goal here is to be able to run this code, make sure this code is parsing everything properly without having to start my server, go to the browser, go to localhost 8080, and then just hope and pray that something shows up. And then if nothing shows up, I go, what do I do? And then you panic or go to office hours or something. I want to show you a better way. There are much better ways to test your web apps, especially if you can parcel off the functionality. It's nice to have this server part doing very, very little, and then having that use a whole bunch of separate modules, and then those modules can be independently tested, and then your handle method should only be taking all those modules and mashing them together to limit the amount of testing you have to do with the browser. You shouldn't do much of any testing with the browser itself. even though that is mostly how everyone will test in this class, even after this, but it is what it is. And then Python has a built-in way of testing. We don't have to, if you want to use a formal testing library, knock yourself out. I'd be thrilled to see that. Python has a simple way to do that with just the assert keyword, though. I'm going to assert that request dot, say, HTTP method version equals HTTP slash 1.1. That's what it's always going to be. So I can assert that, and then if that assert fails, it'll tell me. And if it passes, it won't tell me anything. Just like a unit test, just like a test case in a unit test does the same thing. The one thing that we need is an input. We need a request. So we need a request, a valid, well-formatted request to give this thing. Well, guess what? I set up the handout code to print those for you. I'm going to highlight this, copy it. I even have the B here. It's a byte string. I'm printing it as bytes in the handout code. Paste. I have a test case now. I have my input for my test case, and you might want to trim this down a bit. I would get rid of some of these extraneous headers. Like that's way too much. I'm going to get rid of all these, actually. Just make sure when you're deleting them, you have all your /r/n's lined up the way you want them to. So I'll get a smaller one here, 2 headers, and I'll make sure that I have everything the way I want it to with, let's see, assert request dot path should be slash request dot method should be get assert host in request headers assert request headers of host equals, which I'm pretty sure I can use equal in, oops, I almost did that wrong, equals this. And I went almost the whole way, but I'm running out of steam for the last one. But I do connection keep alive as well. And then run this code.